Hey guys, in this one we've got another coordinate geometry exam question. So this time we're looking at the equation of a straight line and then doing some tricky coordinate stuff. So, without further ado, so the point A has coordinates -2, 5, and the point B has coordinates 8, -6. So part A wants us to find the equation of the line AB, giving our answer in the form Bx at Qy equals R, where P, Q and R are integers. So let's do just that. Okay, so I always like to write my coordinates out on the question. So we go A, -2, 5, and B, 8, -6. Okay, so we want to find the equation of the straight line joining these guys together. Now, to be able to do that, we need to work out the gradient. So, gradient is difference in y over difference in x. So, I'm going to do -6 -5 over 8 -2. So that's going to give me -11 over 10. So the gradient on my line is -11 tenths. So now we know our line has a gradient of -11 tenths. We now need to stick that in. I'm going to use y equals mx+c. So we now know y equals -11 tenths x plus c. Now we need to find the value of c. So to do that, we substitute in one of our sets of coordinates. So I'm going to go for -2, 5. So -2, 5 tells us when x is -2, y is 5. So we get 5 equals -11 tenths times -2 is positive 22 tenths plus c. So we've got 5 equals, well, we can divide that by 2, so 11 fifths plus c. So if we take that away, I would think of 5 in terms of fifths, so we get 25 fifths minus 11 fifths is equal to c. Therefore, c is equal to 14 fifths. So the equation of our line is y equals minus, where are we? -11 times x plus 14 fifths. We want x and y on the same side, so we would get 11 tenths x plus y equals 14 fifths, and then we don't want fractions, so we want everything to be integer. So I'm now going to multiply through by 10. So I'm going to get 11x plus 10y is equal to, well, multiplying by 10 would give us 140 over 5, which is going to simplify to 28. So, there's the equation of a line in the form that we want it. And then we got quite a tricky part B, so the point C has coordinates k plus 1. Given the angle ACB is a right angle, we want to find the two possible values of k. So, first of all then we need to decipher this a bit. So, if ACB is a right angle, then what does that tell us about AC and BC? It tells us they are perpendicular. So we know AC and BC are perpendicular. So, what does that mean? Well, if two lines are perpendicular, it means their gradients multiplied together to -1. So if we find the gradient of AC and the gradient of BC, multiply them together, then we know that has to give us -1. So, let's do just that. So, let's first of all then work out the gradient of AC. So, we know that C has coordinates k plus 1, A has coordinates -2, 5. So, we could say that this gradient is k plus 1 minus 5, so the difference in the y coordinates divided by k minus 2. Now that is going to give us k minus 4 over k plus 2. So that's the gradient of the line AC. Now let's find the gradient of the line BC. So for the gradient of the line BC, I need to remind myself of the coordinates of B. So 8 minus 6. Okay, so the gradient then for BC we can say is k plus 1 minus 6. So plus 6 over k minus 8. So that simplifies to k plus 7 over k minus 8. So what we've done there up to now then, we have found the gradients of AC and BC. Now, because we know these two lines are perpendicular, we then know that if we multiply these two together, we get -1. So, k minus 4 over k plus 2 times k plus 7 over k minus 8. We know that that is equal to -1. So we're now just playing around with some cheeky quadratics. Well, we will once we multiply these fractions. So, up on top we got k minus 4 times k plus 7. So we're going to get k squared add 7k minus 4k So plus 3k, and then minus 4 times 7, so that's going to give us minus 28 over, well, k plus 2 times k minus 8 is k squared minus 6k, and then minus 16. So we know that that is equal to minus 1. If we then multiply both sides by the bottom, we're going to get k squared plus 3k minus 28 is equal to minus k squared plus 6k and then plus 16. So we then want to get everything on the same side, because we are now in quadratic territory. So we're going to add k squared, so we get 2k squared. We are going to subtract 6k, so we're going to get minus 3k, and we are going to subtract 16, which is going to give us minus 44, and that is equal to 0. So we now need to solve this quadratic for k. Okay, so believe it or not, we can factorise this guy. I know it doesn't look very nice, so you could complete the square or use the formula. It factorises though to 2k in there, k in there. Now, what multiplies to 44? Well, 11 and 4 works. So, if we put minus 11 in there and plus 4 in there, 4 times minus 11 is minus 44. 4 times 2k is going to give us positive 8k, but then minus 11 times k is going to take us down to minus 3k. So, k then is either, so if we set 2k minus 11 equal to 0, we would get 11 over 2, or we get k equals minus 4. So there are our two values of k. That's it for this video. Hope you found this useful. If you want more questions like this, let me know down below in the comments. Take it easy, guys.